All right, let's get started. Good morning, everyone. Hope you've had an engaging morning. You'll hear that word a lot, obviously. And in this session today, I will share a little bit more about the thought behind an engagement database, why it matters, why it's important, but more importantly, deep dive into the architecture a little bit. And take a look at what those blocks that you saw on the screen when Ravi was talking about the architecture are really all about. What mobile is about, what a query is about, what the scale-out architecture is about, and kind of dive deep into it. Also, I will share some of our core principles from a design perspective as we've built this, the architecture up. To explain how it all works internally. And there's multiple sessions later this afternoon which will give you even more depth into many of the areas that I will talk about. Now, you all see that the world has changed. The way we engage has changed. The way we interact with each other has changed. And that was obviously the theme of the morning today is how we interact, how we experience things. That's what it is about today. And our expectations as consumers have changed as well. I mean, we're kind of spoiled now, right? We expect great experiences, and the switching costs to another app are so low that we could just switch over to another app and another business. And so as a business, we need to innovate, and we need to set the bar high for an experience perspective. It's not just about transacting. Over time, interactions will drive transactions. If you don't have the amazing interactions, you will never get to the point of the transaction. And so the point of experience and engagement is the engagement database itself. It is these amazing interactions that will eventually lead to transactions. And as we looked at this morning, it's across industries. So it's across e-commerce, where you have a great browsing experience. You have recommendations. You have a customized experience, a context-aware experience. And eventually, you hit that Buy Now button, which results in a transaction. You look at travel with Look to Book. When you go onto Expedia or Kayak and you type a simple query, which is SF4 to New York, which is what I was doing a week ago, you are creating an explosion of queries, which means ops per second at the back end for an Amadeus, which is resulting in 1,000 to 1 operations per second on the back end, which means if you aggregate all those queries together, they need to operate at 1 million, 2 million operations per second on a single cluster. So that's kind of the scale that the explosion kind of results in. Same thing with digital media, right? You have a great browsing experience. You look at all the shows you want to watch, and then you decide, okay, I have Saturday night, I have 3 hours, the baby's sleeping, I'm going to binge, and then you go for it. But it's that experience before that actually results in that. And finally, even in financial services, whenever a credit card is swiped, what happens at the back is not just one transfer of, from one account to the other. It's actually fraud detection. They're looking at behavior patterns. They're looking at, what you've spent money on in the past week, in the past 2 weeks, in the past month, and resulting in that your profile is getting scored, and there's scans happening at the same time, which is, again, there's a lot going on before that transfer happens. So I think you get the point. At the end of the day, what we're increasingly going to see is that engagement happens before the transaction on the transactional system. We see the world of databases changing to fit this model, right? As a database person, I've always been, and you guys have probably seen, the operational database, analytical database, right? That has kind of been imprinted in our brain for the last 30, 40 years. But it has to change. If experiences have changed, why hasn't the database, right? If interactions are a lot more, why are we still focused on the transactions? This is where the engagement database comes in. It's not just a cache sitting on top. It's actually its own system sitting next to the transactional database, which is going to allow you to eventually get transactions into that transactional system. And of course, you have your data warehouse, you have your Teradata and your Hadoop installs and all the other analytical installs, a lot of batch processing at the back. But over time, the interaction and insight actually needs to happen at the point of interaction. That's what Ravi talked about with our analytics preview, which is real-time analytics within the engagement database. So that's kind of what it will be increasingly about. You saw the slide this morning, which is about kind of 6 core attributes of the engagement database. And it really is about these attributes. I mean, can you imagine an experience without mobile devices? If a website doesn't look great on your device anymore, you're probably going to switch over at some point because it's hard to use, right? From a deployment perspective, cloud native, right? You've got to, maybe you start with bare metal, then you move to VMware, then you move to, AWS, right? Then you're like, okay, containers, Docker. You need a database that will go along with you wherever you go from a deployment perspective. And so cloud ready and native is really important. And there's many others that we'll talk about. But what it comes to is the data platform itself, right? This is Couchbase, right? This is one system with everything you need to create that engagement and that experience. And today I'll walk you through these blocks. We'll talk about the core design principles, which is the foundation of the architecture, which is the elastic scale out, as well as the memory first. And then we'll look at what you can do with it, which is KV, right? Key value access, query access, search, mobile, analytics, all of that built into a single platform where you have to talk to the other databases. Remember the slide with the 3 circles? Well, you still have to talk to the transactional database, and you still have to talk to the analytical database, and that's where the connectors come in. So SQL and the big data connectors are first-class citizens of the platform. They're integrated into our core data change protocol and are really important. And this engagement database is not just going to store blogs and tweets, right? It is human data, it's personal data, it's financial information, it's customer data, it's profiles, it's credit card information. So security is really important, and it's actually built into every layer of the stack. So let's take a look at core design principles. First one, elastic scaling architecture, right? In today's day and age, it's very hard to predict what your demand is going to be, right? Pokemon was a great example where they planned for 8x for their max limit, and they blew that out by a huge margin, right? And so if you don't know what your demand is going to be, how do you plan for it starting off? You need a database that scales out or scales up or scales in, whichever way you need, because sometimes you want to scale out for peak workloads, but then you want to scale down when you're back to the usual workload. And that agility and flexibility has to be built into the system and its core. So when you start off with your dev instance, it might look simple like this, right? All nodes look the same. You have 2 nodes, and every service is kind of running on every node, right? Just 2 nodes. But then you move to QA, and the system grows, and you have 4 nodes with maybe a lot more data because you want to test more data, and maybe a global index that's on 2 nodes, the service that's on 2 nodes. You want to have some separation of your query processing, which is kind of more CPU intensive, your index, which might be more memory intensive, and running FullText Search with 5.0. And then you go into production. And that changes the game. And suddenly, you have a 12-node cluster or more where you want to scale these services based on what you use. Maybe you don't have maybe you don't have the full text capability initially, right? You have query index data. That's good, but you want to add search. You don't have to redistribute that data ever again. The data, which is on, in this case, 4 nodes, can stay on 4 nodes. You can just add nodes to add services in the same cluster. All of this managed in a single cluster. This is what we called multi-dimensional scaling. It allows you, it's kind of microservice within the database, right? Because I'm sure all of you understand the value of microservices outside on the application side, but you want workload isolation even within the database, which is where the action happens in some sense, and the query workloads looks very different from the index workload, which looks very different from the key value workload. So this is how scaling is built in to the architecture. Of course, it's a shared nothing distributed architecture, which traditional databases, relational databases don't have. There's always some shared instance of either a disk, shared, something is shared. You have a SAN at the back. There's something that is shared. And this is kind of completely a shared nothing architecture with a cluster manager, if you notice, on every single node. Right? So that same cluster manager is running on every node, and that's talking. That allows for the communication across the nodes to get that scale going. Next is memory first. When I started off writing index kernel code for DB2 many, many years ago, it was all about page layouts, right? 4K, 8K, you had to kind of define that buffer pools, table spaces. You were designing the database for disk because that's what everybody was using. But the game has changed, and the world is in a memory-first mode, if you will, with eventually disk, going away altogether. So the access that you have is in memory. So you only kind of interface with memory from an application perspective, right? You're streaming, every update that happens to data has an in-memory update to every other component. You have in-memory replication, you have in-memory indexing, obviously in-memory data, right? So everything is in memory, including cross-data center replication, which is over a wide area network, but even that is memory to memory, and so you're basically working at the speed of memory all the time, as opposed to the speed of disk, which slows you down. So this has to be built into the architecture, because otherwise it gets in the way, right? Disk gets in your way, and this allows you to basically work at the speed of memory, which means update workloads, right? Insert workloads, balanced workloads, read-only, any kind of workload works fine. And so as I mentioned, those are kind of the core, but there is one that's integral to the engine itself. When you think of it, why does all this work at the speed of memory? Everything is asynchronous. Everything is, and this is a fundamental difference when it comes to transactional databases and Couchbase. Persistence is asynchronous, replication is asynchronous, indexing is asynchronous, text search, inverted index is asynchronous, analytics service is asynchronous. And so you are never waiting for another component, which means that you can get back to your user or the application faster, but all the other components are still getting in-memory updates and keeping up in real time, as opposed to a system where, I think the word that was used this morning was chewing gum and baling wire. When you have multiple systems together, you have connectors, and you have, it's the database sprawl with all these different systems, it gets harder. So this is actually how it works. So internally, a document comes in. It's obviously JSON. And it gets replicated across, it comes down to disk. It is all asynchronous, right? The request has already gone back up to the application as soon as that document has arrived within the memory or the inbuilt caching layer of Couchbase. And then you would ask the question, if you haven't already thought about this in your mind, is, well, if it's asynchronous, then configurable what is the consistency model here, right? Because traditionally you would expect in a transactional system full ACID compliance, right? Two-way commit and all of that. Well, from a data consistency perspective, Couchbase is strongly consistent. So if you write to the system, that's what you get back, right? There is no eventual consistency for data, because you are going to an active data set and you're getting that back. You can always read from the replicas, but that's really not needed. That's more from an availability perspective. For your primary access, you're only working with active data, and that is strongly consistent. From a query perspective, since it's asynchronous, you have options. Right? It's not one size fits all. You might want to have maybe the index a little bit delayed, or you might want that point of time, give me what the index looks like for the query. You have those options. So you can set your own level from a query perspective when you're querying information. So coming back to the data platform itself, right, this is kind of the core. This is what it looks like. And these are the foundations. So elastic scale, memory-first architecture, and the core database engine, which is native JSON and indexing and all of that, is the completely asynchronous approach that I talked about, which gives you the flexibility and the performance that you've heard of this morning. Now, next, let's walk into the data capabilities. Right? Now that we've established this foundation, which is the core architecture, let's build on top of it. So, key value access. Key value access is the fastest access to data you can get. Right? So when this morning, Chris was talking about M platform and storing a billion users, that latency he's talking about, 1 millisecond or less, that's their SLA, right? He'll probably call our support teams if it becomes 2 milliseconds or so. So that is key value access. It's incredibly fast, and it's the fastest access you can get, right? But if it's not built on the right architecture, other systems who claim to be key value won't be able to give you that 1 millisecond response times. So it is fast, it's highly replicated, so the data is always available. And at the end of the day, we're working in documents, right? So you have a document, you store it inside the cluster. From an application perspective, whether it's 1 node or 4 nodes or 10 nodes, it doesn't really matter. It looks like just one set of nodes, that's Couchbase, right? So all of that shared nothing architecture and the hash distribution is transparent to an application developer. The same code that you write as an application developer or an architect for 4 nodes is going to work on 5, on 10, on 100. And so there is no change that you have to make, which you would need to make in hash partition systems where you have hotspots and the data is not uniformly distributed. Moving on to query. So query with Nickel for JSON is very, very powerful. We introduced this about 2 years ago, and with every release, it's just getting more powerful. With Nickel, you can look at any part of your document. You can query into any part of your document. You can go into arrays. We have array indexing built in, so those queries are actually optimized. And we have a range of indexing all the way from covered indexes, array indexes. They're also in memory, right? All these indexes are in memory. It gives you that richness and power that you would want to build rich applications. Of course, along with that goes a fully, highly parallelized query processor and a query engine and multi-stage, stateless kind of engine at the back. It is an independent service, right? It is an independent service, which means that our key value workload that we just talked about, which is very sacred, do not touch, right? That does not get impacted no matter what queries you're running, right? It's really important. Because traditionally, you've all heard this from a relational database perspective, do not run select star from table on your production system. You're going to have a problem. But I'm not saying you do this on Couchbase, but technically, you could actually have a query running on Couchbase that will not impact the key value because it's an isolated service. Moving on to FullText Search, which is brand new, fresh off the rack in 5.0, which we just introduced. And this is now going to give you richness at a different level, right? Which application is complete without that search box these days, right? And why do you need to have another system on the side to take care of it? Why can't the database just take care of it for you? And that's kind of what we've done with FullText Search, right? Text search isn't new. Lucene has been around for a long time. There's others like Solar and Elasticsearch, which some of our customers actually use. But they are very excited about having search built in to the system, right? Because why duplicate that data Why maintain a connector on your own where you and your admins need to manage, is the data getting replicated? Oh, this stopped working 2 days ago? Oh my gosh, we have to start replicating again. So it's now built into the database, into the same great in-memory data streaming that we have, where the inverted index gets updated, and you have richness with faceting and relevance-based results. And so you can create these applications with Couchbase. So this is just a simple example, right? For those of you who's like, what is an inverted index? Well, you store words. You actually store words in there, and then you point to the documents that those words belong to, right? So it's kind of a reverse lookup, and this is just the beginning. You should attend Marty's session this afternoon, which will go much deeper into these the details of FullText Search. Next up, mobile. Now, mobile, of course, it's understood that engagement and experience, mobile and that goes along with each other. But again, why have a separate system to just manage mobile? Why not in the same platform? With Couchbase, we actually have the sync gateway that replicates data and changes that happen in the cloud in your server down to your device, right? So let's say you have an application that, a web app, right, that's running on the server, and you also have a mobile app that's per user where you want that data reflected. That's done automatically for you. So when the data changes on the server, it changes on the device, which is kind of user level data, for one user. It's much smaller scale, but it's even more important to personalize that data for a great experience. And it's not just a cache. So if you are not connected, you still have it. You can still actually make changes. You can reflect that information in the device on the database on the device, and it will sync back up. And there's an entire mobile session. If this is something that interests you, I would recommend that you attend some of the sessions there on the new functionality, especially with querying and full-text search, and so on. And then finally, analytics. With engagement over time, recommendations and predictions will need to be a part of it. And today, it's an entire different market, an entire different database. But over time, there will be slight consolidation, especially in the area of real-time analytics, where you want that insight at the point of the interaction itself. And so with analytics, again, it's an independent service that scales independently, and you have no ETL requirements anymore. Today you probably use an Informatica or a Talent or one of those to move it from your operational data store to your data warehouse. Then you run, you have ETL in the middle. You probably do some ETL on the top of the data warehouse. And you probably still continue that from a batch perspective or from a business reporting perspective. It still makes sense. But when you want to get insights about purchasing histories and things like that, you want it pushed directly into your operational system. And that's kind of what analytics does. The difference between Nickel and analytics is that Nickel is for very targeted queries, right? It's like I go into an application, all right, give me all the orders that Dipti has for the last 6 months, right? Very targeted query, which is Nickel. Now, if you want to ask a question, a different question, which is, let's try to find all the different recommendations based on what Dipti's friends have been buying over the last 6 months, and maybe people at her company are buying, and her, there's all these different aspects that you can join together, and very soon you're going to get a 5, 6, 7, 8-way join across many different attributes. That's what analytics will do. It's very fast response for very, very complex queries. So you don't actually need indexes to be built at the back. The data is stored differently to be able to do table scans very, very efficiently, and it's highly parallelized, right? So the same query gets split out many, many times, aggregates the results, very fast at aggregations and counts, all of that stuff. So that's kind of where analytics comes in, and that's how it's different from a nickel, which is a very pointed query about smaller piece of data. So this is kind of the platform, right? Going back to the platform, we talked about the architecture. We talked about how it gets accessed from using the different services. And then I want to take you quickly through the SQL integrations, big data integrations, our security capabilities, and cloud. But let me just pause here for a minute and see if there's any questions out there. Yes, sir. Mm-hmm. Analytics. Okay. There's actually I just got Q on time. There's actually a great session, if you can attend. I would recommend that David and Till are doing on analytics, and we'll let you know what time it is right after this. Essentially, the service takes updates that are coming in from our DCP stream, if you're familiar with this, that's the database change stream, and is writing it into a separate set of nodes in a different format. So so that it's easier to actually aggregate data, right? And it is still a row, kind of a record format if you go. It's not kind of column, because column doesn't make sense for JSON in that way, right? It's just documents. So it's a record format, but it's the engine that is the difference. It's highly parallelized. So you have, you could have, M-way parallelization based on how many cores you have, how many processors you have, and so on. And that is that's going to give you the performance for a 5-way join, or complicated joins with group bys and aggregates that are built on top. And I won't go into more details here, but I will point you to that session. Certainly, they will go into a lot more detail in that session. Any other questions? Go ahead.
Related to the analytics
yeah.
question, does that also include the nickel query syntax? And how does that compare to, say, graph databases?
Good question. So for analytics, at this point, we are using, it's very similar to nickel. It's actually a superset of nickel, if you will, called SQL++. And this is a language that actually came out of UC San Diego, and from an academic perspective. And we actually worked together with the SQL++ team, who was helping us build analytics. So it gives you the same power, but it's more, right? Because the nickel doesn't support complex joins. It supports joins, but it supports primary key joins, right? Versus analytics, which will go much more deeper into more complex, answering more complex questions. Just one more, and then I'll go in. Yeah. Correct. Mm-hmm. 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 Good question. Mm-hmm. Good question. So if you notice, you don't see views on the top there in one of those boxes. I have KV, query, search, mobile, and analytics. Views is built into every node. So it's, if you will, it's a local index. It's a local index. Every data node has its index, right? The indexes that support nickel, which is the in-memory indexing, or what we call global secondary indexing, is a global index, which means that it's an independent service that can scale out as many nodes. With any local index, this is foundation of any database, right? If you have a local index, you will have to scan across all the nodes to get your results. On a global index, you can go to one node or two node and get the results back. And so you can see that the impact that the global index is going to have is significantly less than a local index. Given that views are a local index, it basically has more impact. And more customers are basically using our memory optimized indexes for querying with nickel as opposed to views for that reason. Now, views are very good for certain things, but it is not a separate service, which is what you're talking about. Compare this with FullText Search, which is its own service, right? So you have updates coming into the system. They're going into the inverted index, which is a FullText Search index, which is a completely set of separate servers. And only when you need to access a document, a specific document, like let's say you have a search result, right? And you click on a document is when you'll actually do the key value. And so key value performance is not impacted. All right, let me take a couple more slides, and then I'll take a couple questions at the end. So full stack security, we have security on the server, on the wire, on the device, and specifically authentication, both sides, server and mobile. We're introducing RBAC for users and applications in 5.0, so that's on the server side. Mobile with Sync Gateway already has this built in even today. We have auditing on the administration side if you want to audit what kind of changes are happening. And then we have transport layer sync. You kind of get the picture. So security is increasingly important, and every release we add more and more functionality to beef it up. Next up is SQL and big data integrations. So this is talking to that relational database, that transactional database, and on the other hand, talking to the analytical database, right? And so we have your classic ODBC, JDBC connectors, integrate with your ETL, if you will. But what we are increasingly seeing more of our customers focused on the right of the slide, right? Which is Spark and Kafka and visualizations that are using JSON as opposed to rows and columns. And the reason is that when you have JSON and you convert it to rows and columns, it's like there's a lot lost in translation, right? You're losing a lot of richness because of that conversion. You'll get something out of it, but you now need tools that actually work with native JSON. And we'll see an entire ecosystem just being developed, like Slam Data, who's here presenting, building tools with native JSON, as opposed to taking native JSON streams from systems and converting them into rows and columns, which can only go so far. And then finally, it's built for any cloud. We always get this question, right? What should I run on? Should I run on hardware? Should I run on VM? Should I run on the cloud? Should I run on the Docker, on containers? And the answer is all of the above. Now, obviously, it depends on your environment. It depends on your use case. For customers that are running at very, very high intensity, right? We're talking 3 to 5 million operations per second on a 30-node cluster, right? Bare metal is what they run, because every layer you add, you're just taking a hit, right? But these are mission-critical revenue-generating apps, right? And that's what they are looking for. On the other hand, we have customers who want that flexibility, and they're running on VMs or AWS, Azure, name the cloud, if you will, or Red Hat, OpenShift, right? That's one. In fact, the Comcast session this morning, they're running on Cloud Foundry, right? Which is another PaaS. So there's multiple options you can run on any of these, and work with your Couchbase expert, right? They help you figure out what's the right solution and the right option for you. So Docker, OpenShift, all supported. Increasingly, we are seeing Kubernetes, Mesos, and so on coming in as well. Containers are great, but you still need to manage containers, and that's kind of what people are realizing, and that's where the orchestration frameworks start coming in with Mesos and so on. And finally, I want to kind of end on why people choose Couchbase, right? If you leave this room, and I want you to take this away, is it's one platform, but there are key differentiators, right? Mobile, right? You won't get that you won't get all these in a single platform, right? Key differentiator for us. Nickel, the power of SQL, leverage your existing skills with your, that you already have in your team, but with the same power and the flexibility of JSON. XDCR, which is a cross data center replication. MDS, multi-dimensional scaling, we talked about. And then, fully memory-first architecture, which is kind of the core of the system. So it is a single platform built for engagement that can give you all this in one place. So I'll take more questions now. Thank you very much. I think there was a, yes, question. Can everyone hear the questions, or should I repeat the questions? Okay.
Continue the conversation about views. The now remaining piece of functionality that we are hoping is getting to a size is the ability to store the aggregates. Views provided that capability. We really like that.
Yes, yes. Yes, great question. So we should actually talk with some of the architects later to make sure they hear that. So the question is around views allow you. So a view in Couchbase is basically a materialized, it's a materialized result set, right? And that you are probably familiar with from the relational world. It's not very different, but it does have a B tree at the back, which is the index itself, and it stores a lot of the aggregates into it. So when you query it, it is very fast. With indexing, with global indexing, which I was just talking about earlier when comparing global indexing and local indexing, with global indexing, it's built for kind of a pointed query, right, as I talked about. And so it's not as built for aggregates, if you will. It does better with, it's highly optimized for where for predicates and all sorts of other things. There is more optimization in 5.0. So 5.0, we've actually improved the aggregate performance. But if you have custom aggregations, then analytics is actually what will help you use that, because that functionality of views is not so much on the real-time aspect. It's actually more on the real-time analytics side of things. And I would recommend attending the analytics session to really understand how aggregates work within analytics, so that that piece is kind of taken off to a more global service-oriented architecture. Question? Can't say that in the same sentence, huh? So the question is, you said no ETL, but you also said real-time analytics in the same sentence. How does that work? With Couchbase, with our analytics preview, we will have a service that's running within the cluster for analytics. So the no ETL is because the database updates that are happening on the operational system, they're automatically getting pushed into the analytics service or the analytics node, and so you don't need any ETL on top. You can then, and once the data is stored on the analytics nodes, you can then ask those complex queries or answer those complex, those questions directly of the analytics service, where the data is stored in such a way that your multi-way joins are a lot more efficient, as opposed to Nickel, which doesn't support 5, 6, 7-way joins. Okay. Question?
Based on that line,
yeah.
There are some use cases which still ETL, like informatic and all these are useful, but the kind of things your analytics service is doing, it's doing everything. I mean, it does. What is that you're missing?
So, well, ETL might still be needed for your data warehouse for offline reporting, right? You still might need systems which you're running off a different data set for offline purposes. The purpose of this analytics is real-time analytics of behaviors and recommendations, right? There's many other use cases for analytics, right? And ETL, you might want to move it to Hadoop. You might want to do something else with it. So there's always use cases for it. We're seeing Kafka being used more and more instead of ETL, right? It's the same thing. It's just in memory, and it's strong technology. So to move it off to other systems and do other things with it, because at the end of the day, Couchbase, no matter what we're talking about, is still in the real-time engagement world, right? There's a big world outside of that as well for many other things. So we fit into that world with these connectors that you could use when needed. But analytics is more in the context of recommendations to create personalized experiences. Hopefully that answers. And one last question, David, if I may. Go ahead.
As part of our solution, we were going to have 3 clusters of 6 nodes.
Okay.
But it's one application.
Okay.
And before we heard about version 5, we were going to have to do custom sharding in between that.
Mm-hmm.
We heard some kind of talk Does that address this, or is that more on the failover side?
It's more on the failover side of things. So let me repeat the question. The question is, we are planning a deployment with 3 clusters, 6 nodes each, and do you have a solution to address that, right? So the clusters are not meant for availability. They're actually meant to separate out the systems. Is that correct? To separate out the data? Is there different data in each of the each cluster?
No, yes.
Okay, so if there's different data in each cluster, then there's no XDCR essentially between them, right? They're separate clusters for different applications, and you are doing application level, splitting across for these clusters. Now, there are customers who don't do that. They'll just have that in a single cluster where you don't need to shard. We do have features like rack zone awareness, where even if it's a large cluster, you can make sure that your replicas are on separate physical nodes or in separate zones or separate regions, so you're protected from that. So the question is, should this be an 18-node single cluster, or should it be 3 clusters with 6 nodes? That's one conversation, right? And it depends on your use case. And the second question you asked is, what is this multi-data center awareness? So multi-data center awareness addresses the availability question. So if you have a 2-cluster deployment where data is getting replicated bidirectionally, both sides, then today when you build the application, you talk to one cluster, right? The recommendation is it's a sticky app. The app is synced with a cluster, and it's a set of application servers. For your other cluster, you have another set of application servers, right? And that's kind of how the deployments work. With multi-data center awareness, the same application can talk to both clusters. So if you see that your first replica is down within the cluster, let's say, because you already have intra-cluster replication. One replica is down, another replica is down, you're still not getting a response, you might just want to talk to the other data center and get that information back. So it is more from an availability standpoint. That code is built into our client, so the clients are now smart about clusters in that sense as well, and can go and reach out information from another cluster, not just the one that they have been talking to. So hopefully that explains the question. Any last questions? So it is, the question is multi-cluster deployment in 5.0? And the answer is, well, it is actually a client-side functionality. So in some sense, it's separate from the server binary itself. It will be first in our Java SDK, as we start off with Java and then we move to the other SDKs. And so it's a client-side functionality that's part of that will be a part of 5.0. All right. Well, with that, thank you very much. I hope you enjoyed the session. Just one last note. A colleague of mine we were talking last night about engagement databases, and he made he said, somebody's asking, are you introducing a marriage registry of some sort, or matchmaking of some sort? And he reminded me that 30, 40 years ago, the same conversation happened. There was this new thing called a relational database. And the relational database, was it about relationships and dating? And so in some sense, the world has evolved, and it's time that the database world evolves to a new kind of database. And I hope you got a look into what that would look like. Great, thanks everyone.